Hello and welcome back to Calculus2 section 8.1 on basic approaches in integration. This is technically integration review, stuff you learned before in Calc 1. We start by understanding that we are supposed to go back to 4.9 when we learned antiderivatives for the first time and learn all of those, or relearn or review all of those 17 basic integrals, which include integral of a constant, integral of x to the n, integral of sine, and integral of e to the x, and so on. So, basic integration is in 4.9, meaning the list, right? The list. And 8.1, page 520, also has the same list. One of the examples is that, let's say, the integral of e to the ax dx is e to the ax over a plus c. Another example is e to the x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. So, and I'll put 3 dots. There are 17. I gave you 2 out of 17 that are on that list. ln is not on that list because integral of ln is not a basic integral. We are going to learn that later. Tangent is also not basic. We've seen some of those before. So basic integration. Then we have algebra approach. So some problems can be just simply massaged by algebra and changed so that you can do the problem easily. Here is an example of that. Say you have integral of x squared plus 6 divided by 4 square root of x dx. This looks terrifying because you see the square root, right? And you say, well, I need another square root so I can use substitution. Hold on, right? Hold on. Can we use basic algebra before you go nuclear, right, which is u sub? Can we use basic algebra? This is a fraction with addition in the numerator. It can be split in 2 fractions. As soon as you do that, when you split in 2 fractions, you just have 2 basic integrals to deal with. Let's see. If I split this into 2 fractions, I get x squared divided by 4 root x plus 6 over 4 root x dx. We can do this because plus was in the numerator. You have a 4 root x to be common denominator, so you can split this. Now, you combine exponents and you get x to the 3 halves divided by 4 plus, and now 6 and 4 cancel to 3 halves, x to the negative 1 half, everything in parentheses dx. Both of these are in the form of this. You have x to some exponent. So you just apply that rule. No complicated integration in this case. You used algebra. So integrate, you copy 1/4. Then you have x 3 halves plus 1 is 5 halves. So 5 halves divided by 5 halves. Plus copy 3 halves. X to the, oops, we need a fraction there as well. Negative 1 half plus 1 is positive 1 half divided by 1 half, and then plus c. By the way, this plus C is not optional. 10 problems, 10 integration problems, 10 plus C is missed. Minus 10 points, you lose a whole grade. Don't miss on plus C. Now, I have x to the 5/2 over 10, right? Because 4 times 5 is 20, divided by 2 is 10. You can do it that way. Plus 3x to the 1/2 plus c. And that's it. We're done. Now, this would be 100%, right, on the test if you have the problem like this. You can make this prettier by factoring, if you so desire, because you can kick out x to the 1/2, right? And that would make this nicer as the answer. But you don't have to, right? That's if you want to be special, if you want to feel that you are better than others, right? Then you factor out square root of, right? You factor out square root of x. It's mathematical flexing, right? Because you can. So you go, yeah. Right? You factor out root x, you get 5 into a 4 over 2, so you get your x squared over 10 plus 3 plus c. That's the boss right there. But both of these are full credit. So it's either basic integral or it's algebraic manipulation that puts the integral to be a basic integral, right? And finally, the third flavor of integrals that you get prior to chapter 8 is the U sub. And then there is a subcategory of that called back substitution. And I have to review both, right? U substitution is primarily going to be used when you are dealing with composite functions, when you are dealing with, let's say, hyperbolic problems, right? We did example with the square root earlier. I can I'm gonna try and make up one over here. See, so let's say you have cosecant hyperbolic of ln let's go simple. ln x cotangent hyperbolic ln x divided by x dx. So this is what a basic U sub would look like with hyperbolic functions. Now, before you go full panic mode, what do you mean basic? This has, 5 different functions on a pile. Yes. But when you are dealing with, good one. When you are dealing with U sub questions, you need to think about function derivative pair. Do I have a function and its derivative present? And if I do, I should be able to squeeze in U sub. Later on, this kind of thinking is going to help you distinguishing U sub problems from by parts problems. So, yeah. So when I go here and look for function derivative pair, I see that I have ln x and I have 1 over x. That's a U-hoo right away, because u equal ln x and du equal 1 over x dx is exactly what we need to solve this problem. So I have integral of cosecant hyperbolic u cotangent hyperbolic u du. And this is now a basic integral from hyperbolics, and it becomes negative cosecant hyperbolic u plus c. Now, right, I don't care about u, I care about the x. We go negative cosecant hyperbolic of ln x plus c, and that would be the end of the journey in this case. It looked terrifying. 2 lines, right? So practice. Practice, practice, practice. I'm going to do now back substitution problem, and then we are going to see if we can do something else from the book. Class ends like at 10, 11. We have time. I mean, if you really want to go, just go. This next one, I'll put the title in blood. It's called back substitution. Problems. And what I also heard sometimes referred as back substitution, backward substitution, or reverse substitution was also used in some literature. So here is an example. It's a procedure. It's not a formula. You're not memorizing formula. It's a procedure. So here's the example. You have, let's say, 4x square root of x plus 1 dx. If there was no plus 1, this would be a joke of a problem, because your root x would be just 1/2, and then you just add the exponents together and you're done, right? But plus 1, and you can distribute. And if you do distribute, right, bringing this x inside and kicking 4 outside, you are going to get the square root of x cubed plus x squared, and then there's nothing outside for u sub. So there's just nothing you can do, right? Well, what you still can do is a u sub of x plus 1. And that will give you that du is equal to dx. Now, if you are to plug that in, kick this 4 outside, you still have this x. And clearly that's a problem. Because once you are done with u substitution, you are no longer supposed to have any x's in your problem anywhere. It has to be u everywhere. Well, we didn't make it, right? Does anyone know the trick? Yes. Beautiful. This is the back substitution. Yes. You solve this one for x.
That's actually the only way I can do 2b on the left.
Okay. Apparently it's part of your 2b on the lab. So this part here is what we call back sub. And then you plug that one in right there, and you will now have 4 integral u minus 1 times square root of u du. You get to distribute It becomes u to the 3/2 minus u to the 1/2 du. And here are the basic integrals. So that's called the back substitution method. It doesn't come up that often. It's rare. But once you waste like an hour or two of your life trying to solve a problem, and then you just give up and you go in a software and you go, right? It's usually one of these. So keep it in mind. U to the 5/2 divided by 5/2. Oh, there's a 4 in front. Minus u to the 3/2 divided by 3/2. Plus c. 1/2 and 1/2 will make this into an 8 of u to the 5/2 divided by 5 minus u to the 3/2 divided by 3 plus c. And that's the one that you do not box, because your u is x plus 1. So 8 x plus 1 to the 5/2 over 5 minus x plus 1 to the 3/2 over 5 plus c. We have 10 minutes left, so I'm going to outline some of the homework problems, and I hope you will complete them all in your free time. All right? Problem 22 is really cool. It's sine x plus 1 divided by cosine x dx. Yes? This one? Thank you very much. Oh, that was the 8? Yeah, pay attention. It's obviously 3. All right. Do we all see that problem 22 is split a fraction? And you just have your u sub on the left, which is tangent solution, and then you have 1 over cosine on the other side, and 1 over the cosine will be a secant. So you have the two integrals to deal. You cannot use u substitution on the whole problem to say sine x plus 1, because your du cannot be in the denominator. Du has to be in the numerator. If this problem was flipped with a cosine upstairs, then it's a basic u sub. So I'm just going to say over here as a note, this, there we go, cosine x over sine x plus 1 dx. So this one, split, and this one, u sub. So that's your life. Problem 12, -5 to 0, dx over square root of 4 minus x. This one should be obvious. Is this a basic integral? Can you simplify it algebraically? So it is exactly. Immediately it's a u sub. That's problem 12. Problem 19 looks terrifying. ln w minus 1 to the 7th power times ln w divided by w dw. What was this? U sub. Great. What is the u? It's obvious, right? Very good. What happened?
LNW.
You are on the roll, my friend. The page 524 gives you another 50 exercises, right, to practice. And some of these are spicy. Just want to find something that might trigger you. Ooh, 28. 28 is right. Lock the doors kind of thing. We cannot do u sub here, right? Because the derivative is negative 2x. And you have positive 3x plus 1. So we eliminated basic integrals and we eliminated u sub instantly. Well, what's left? Algebra, right? And what is the only thing that I can do algebra-wise here? Yes, we can split this into two integrals and see what we can do from there, right? So once you split this into 3x over square root of 4 minus x squared plus 1 over square root of 4 minus x squared dx, you have two separate integrals to solve. By the way, generally the integrals in chapter 8 are not this insane. This is literally just mathematical flexing for no reason, right? Over there you have the formulas, you have the methods, and you just use those, right? This is just being creative because you don't have many methods. Now guys, look at this. You need so how we solve the first integral over here? I'll kick 3 outside. How do you solve the first integral? And how do you solve the second integral? So what do you do on the first integral? U sub, right? U sub. Because you have your negative 2x that you need. So when you go over here and say u equals 4 minus x squared, your du is negative 2x dx. All I need is negative 2 and negative half in front, and the first one is solved, right? Follow the 5, 5. How about the second one? Yeah, the second one. No.
Arc sine?
Yes, trig, arc sine, inverse sine. This one, if you sine inverse, that's what's going to happen there. It's going to be sine inverse x over 2. Blah, blah, blah. Now you're going to say, I'm supposed to know that? Well, no. Because if you don't know the formula for inverse sine, don't worry about it. 8.4, trigonometric substitution. You are going to take a half-page calculation to come up with this answer if you didn't memorize the formula from Calc 1. It's perfectly fine, right? Because you can forget your inverse, cosine, inverse, all of the inverse trig ones, because you will be able to get them like this using what we are going to learn in 8.4. So if you know inverse sine formula, it is listed in the table of the basic integrals. It says 1 over square root of a squared minus b squared minus x squared. 1 over a squared minus x squared. It's perfect. Here's your a. It's 2, right, because it's a squared. So a is 2. So it comes out as 1 over a inverse sine of x over a. So this would be 1/2 sine inverse of x over a plus c as the answer for that. You add it to mess you get here, and the problem is solved. So 8.1 homework will open, and that is your section to practice mechanics, so you are able to solve problems. Your Calc2 knowledge is memorizing formulas, and you have about 15 formulas to memorize, which include rotations and areas and volume and length of the curve. 3 or those physics formulas in 6.7, and then a couple of hyperbolics in 7.3. So it should be about 15 altogether to memorize for the test. Test is on 3/5, right? March 5th. So we'll have the review. I'll see you all in 2 days. We do 8.2, right? 8.2, which is integration by parts.